everyone, and welcome to our SocketBox plus BoxLang webinar. If you're interested in learning about SocketBox and BoxLang, then you're at the right place. This is the webinar that we've been advertising, and I'm really excited to share with you all about what we've been working on over the past year and how maybe it can help out your applications. This is kind of the culmination of a blog series that I've been doing on the Ortus Solutions blog. So there's actually a lot more information there than what we're going to be able to cover in just an hour today. But I'll link to those in the slide. And once we share the slides out, you'll be able to follow those links and read over the blog posts if you want. I also have an ongoing Git repo that has examples of how to do everything that are in the blog posts. So there's lots of information for you to be able to dive into with this. And as always, we are on Slack, and you can reach out to us there and ask any questions that you may have. So without further ado, let's get started. So first off, some important announcements that we need to cover. We have Into the Box coming up April 29th through May 1st. This is Ortus Solutions official conference where we cover all things box, including BoxLang and ColdFusion and things like that. We've got both in-person offerings as well as virtual tickets, and it is a great time. If you've been there before, you know exactly what I'm talking about. There's lots of good community stuff. There's great talks and workshops and things like that. And if you haven't been there yet, you'll just have to take my word for it, but you should definitely come. We've got some different ticket offerings. We've got discounts for additional people who might come with you. So if you're buying both tickets for your team or other things like that, it'll be a little bit cheaper. So definitely look into those things. And we're also going to be giving away some special discount codes. So this is going to be pretty great. It looks like this will help out with consulting plans, support plans, BoxLang licenses, a CFcast yearly access for ongoing education. So you're getting a lot of cool stuff. Definitely check that out. All right. And as always, thank you to our Patreon members who have been supporting Ortus Solutions. We really appreciate all that you do for us and how you help us bring these new innovations to the CFML community. All right. So really quick, who am I? My name is Jacob Beers. I'm a senior software developer here at Ortus Solutions. I've been here for a few years now, but my development history extends further back than that. And you can check me out on jbeers.github.io if you're interested in seeing what I've been working on. All right. So the question that we're all here for, what is SocketBox? SocketBox is a WebSocket library for CommandBox apps. It works with BoxLang, it works with Lucy, and it works with Adobe ColdFusion. But in order to get this to work, you have to do two things. One, you have to be running behind CommandBox as your server deployment choice. That can be either using the CommandBox CLI or in a Docker container or something like that as a service. And you have to have the SocketBox module installed and configured, which is mostly what we'll be covering today. The SocketBox library was written by the well-known, maybe the infamous, Brad Wood, and he's done a great job of maintaining it and making it production ready. So you know that if Brad wrote it, then you can rely on it. And of course, this is going to be available on ForgeBox. This is, it already is available on ForgeBox, where we keep all of our packages and modules. So right now you can actually go out to ForgeBox, search for SocketBox, and then you'll be able to see like some documentation about how to get started and things like that. And actually in the various WebSocket implementations that I've done using SocketBox, which is a couple now, I found that the information in that README was totally sufficient for getting things up and running and off the ground. So go ahead and take a look at that if you're interested in adding this to your own thing. I will also, I just want to draw a little bit of attention to this little character here. This is just a fun little addition, but this just goes to show that SocketBox and BoxLang is a match just as good as peanut butter and jelly, which I think that by the end of this webinar, you'll be convinced that that's true. All right, moving along. If you're not familiar with WebSockets, let's talk a little bit about what that is. In a traditional website, you're communicating entirely through HTTP requests, back and forth to the web server. You make an HTTP request that opens up a TCP connection, and then the server interprets that request, returns some sort of data, usually an HTML document or some API data, and then that connection is closed. Well, eventually people wanted to be able to keep that connection open and then have a full like duplex communication protocol where you could send and receive information in real time. This has a lot of different benefits. When you make that connection and then you keep it open, it reduces a lot of overhead. So you're actually sending less data over the wire each time because you don't have to create the HTTP headers and protocol and stuff like that every single time. So it's actually more efficient from a data perspective, as well as from a speed perspective, not having to do as much serialization and processing. Now, another really great thing though is that it gives your server the ability to send information back to the client in a very easy way using just HTTP requests. There are strategies for making that work, but they can be tricky, a little bit bulky sometimes. Usually that's done with like long polling, where you will create an HTTP request and then the server will just hold on to it until it has data that it wants to send. And that can work. But then you have to do all kinds of stuff like managing the state of the HTTP request, making sure that once you send the data back, that you then open a new HTTP request and associate it with the correct user, stuff like that. It works, but it's not as great as WebSockets. So let's talk about some areas where you might want to use WebSockets. They can be great for chat applications, for live dashboards and notifications, for collaborative editing. That's something that you might see in like Google Drive or Jira or something like that, where you get a notification that someone else is looking at the document you're looking at. You can use it for multiplayer games, keeping track of the state of the game and updating all of the clients. You could also use it for like a stream of real-time data, maybe like stock data or a cryptocurrency or whatever. Really shines anywhere that you want access to data immediately. That's kind of the primary use case. But honestly, I think it's one of those things that you can, if you use a strategy like progressive enhancement, you can start off with HTTP and then you can add WebSockets to it and just make the whole user experience more fluid. So I'm a big proponent of using WebSockets. So if WebSockets are so great, why do we need SocketBox? Well, in the past, WebSockets have been notoriously difficult in ColdFusion, but with SocketBox, that's not the case anymore. Brad has done a great job of making not only extremely easy to install and get started with, but very easy to scale and create a robust implementation that you're not going to have issues, that you're not going to end up regretting a year after you've put it into production. And we'll be covering all of those things and try to help you get an understanding of how SocketBox makes that easy. And I just want to throw this out. I've built probably a handful of WebSocket-based applications now at this point, and the first 3 or 4 were built using Socket.io, which is kind of standard in the Node.js world. And the recent ones have been built using SocketBox. And I will tell you right now that I had a much better experience with SocketBox than I had with Socket.io. I think we've just really streamlined a lot of things. So that's not just marketing hype, that's the actual experience that I've had with it. So let's talk about what makes SocketBox special. It's got a very clean convention-based approach. You're basically going to, once you install it, you're basically just going to create a WebSocket.bx file, which we'll look at later, and the different functions that you need to be able to manage the WebSocket connections. There is a STOMP broker that you can utilize in your application, which helps you manage authentication and authorization so that you can build them secure from the get-go. And then there's also tools for load balancing in clustered environments. And this is where it's really important. This is where SocketBox, in my opinion, makes things really easy. The load balancing is one of like the secret gotchas for WebSocket development. And this is something that Brad really put a lot of thought into and made sure that it was as easy as possible for the developer. So we'll talk about that more later on in the discussion. But I will go ahead and call out that there is a blog post specifically for handling load balancing and several different strategies that we give you. So that's a good one to look at if you're interested in that problem. All right. So let's go. I think that the best way for us to learn how SocketBox works is to actually see it in action. So we've got a tiny little live demo that we're going to work on this morning. And it's basically just going to be a click counter, like the hello world of UI design. And, but the state is going to live on the server and it's going to keep that state in sync with the clients using WebSockets. So this is extremely trivial, but I hope you'll be able to see how easy it is to get WebSockets integrated into your application. And then maybe this will give you some ideas that you could build off of. So let's look at an overview first. We're going to start with installing and configuring SocketBox. Then we'll look at the WebSocket BX. We'll kind of cover some of the lifecycle hooks. We'll implement that as a live demo for a shared click counter. And then after that, after we've completed the live demo, then we'll come back and we'll talk about how you can solve some of the harder problems like authentication, routing exchanges, and clustering. All right, so getting started. This is as simple as box install SocketBox. This is going to create the modules directory in your folder, and it's going to include SocketBox and all of its stuff. SocketBox has 0 dependencies. So if you install it, you're only installing the SocketBox code itself. And I haven't gone through and counted, but when I've been looking through some of the source code, I think there's probably fewer than 10 files or something like that. It's really small. So you're not adding a ton of weight to your application by doing this. But once it's installed, that's where we need to start configuring things. There's going to be configuration that happens both in your server.json file and your WebSocket file. Now you'll remember that at the beginning of this webinar, I said that one of the hard requirements was that you have to have your application running inside of a CommandBox environment, right? And that's because part of the way that this is implemented is actually changes that were made to the CommandBox server to recognize WebSocket requests and then pass them along to the ColdFusion application through the servlet interface. And so without that being there, SocketBox isn't going to be invoked within your application. So we basically have to enable that for the CommandBox server and then configure the WebSocket BX file. Okay. So let's look at what a super basic server JSON is for WebSockets. I'm sure that many of you guys are familiar with CommandBox, and so you know that there's a lot that can go into your server JSON to make it exactly what you want for your application. But I've stripped all that out so we can really just focus on what's necessary for running SocketBox on BoxLang. And you can see that it's pretty minimal, right? We basically just say, hey, we want to use BoxLang, and hey, we want to use WebSockets. So let's kind of step through this. The web block includes a lot of different configuration like HTTP bindings, things like that. But there's a new key called WebSocket, and that's the one that we really care about for this demo. And there's really only 2 configurations that we need here. One, setting enable to true. This is going to tell the server to recognize WebSocket connections and pass them on. George, I think that this is available on 6 and above, but I'm not sure if it requires a specific point version. That's a good question, though. I'll have to look into that. But if you're on a recent version of CommandBox, you've got access to it. And then, okay, so we need to set enable to true, and then we need to set our listener, and we're going to set it to WebSocket.bx, right? That's kind of the convention that we're going to use for this. All right. And like I said, this is available in ColdFusion as well. So the WebSocket CFC is actually the default configuration if you haven't set it for BoxLang or something. Okay, so let's look at what it takes to create your WebSocket BX. This is a pretty simple file. There is more configuration beyond this that we'll talk about once we get to the STOMP implementation. But for now, this is really all you need to get up and running. So you create your WebSocket.bx, and then we're going to extend module SocketBox models WebSocket core. And this is just reaching into the SocketBox library and extending that main WebSocket configuration file. And then we're going to implement 3 functions. Right. The first one is onConnect, and this is just going to it's kind of like a listener. This is going to get called when the client connects. We've got onClose, which is going to get called when a WebSocket disconnects. And then we've got onMessage, which is going to be called for any message sent from the client to the server. Now, a couple things that I want to kind of call out here. You can see that all of these, that onConnect and onClose are both calling broadcast message, and they're sending a string value, and there is no channel specified. So when you invoke broadcast message, that's actually going to send data to every single connected client. Down here in onMessage, you can see that we're using send message. We've got our string value, and then we're sending it to a specific channel. So this allows you to target a specific WebSocket and send information to just that person. So what you might want to do is on connect, you might want to store that channel somewhere, associate it like maybe in a map or something like that, and associate it with a user ID. That way, when you have data to send to a specific user, you can get out their channel or channels, because they could end up with a WebSocket connection maybe for every tab, loop through them, and then send a specific message just to that WebSocket. And then I'll also draw attention to this onMessage handler. You can see we're checking to see what the content of the message variable is. This is so that we could support multiple commands. So that might be something like, you might come up with your own little protocol here where you have message equals hello, do this thing, message equals user_list, send back the list of users who are connected, things like that. You can write whatever you want here. It looks like Scott has a question about, can this support other clients rather than just a JavaScript web client? And the answer is yes. It can support anything that can run a WebSocket connection. It can connect to SocketBox as a client. And actually, in fact, we'll talk about this a little bit later when we get to load balancing, but when you have multiple nodes in a cluster, all running SocketBox, and you want them to be able to communicate with one another, they can actually use WebSockets to talk to one another and help keep their state in sync, which is pretty cool. All right, so let's keep going. Covered on connect, we covered on close, we covered on message. So let's see what's next. Okay, so now we're getting into our actual demo. I'm going to show you a couple snippets of code here, and then I'll bring VS Code over and we can actually see things running. And I'll show you the actual application. But I like to show it this way because it helps highlight how little code is necessary to actually get this up and running. So this snippet right here is technically all you need on the client side to be able to connect to WebSockets and actually update your application live. You can see there's a script block where this new WebSocket, this is not a SocketBox thing. This is built into browsers. So all modern browsers are going to supply this WebSocket object that you can instantiate. Once you've got your socket, then you can give it an on-open listener, and then you can give it an on-message listener, where you will be able to inspect the event object and get the data out of it. You can see that this is almost very similar to how the WebSocket BX file is implemented, just with some slightly different syntax. And then here we can get access to the socket and we can send the click event, which will go to the WebSocket thing. All right, so that covers the client side. Let's take a look at the server side now. So this is the implementation of the WebSocket.bx file for the click counter application I'm about to show you. You can see that it is, and actually I've made a few changes to the live demo, which I'll go over once I open that up. But you can see we've got our on connect and on message functions where we're handling the state of things and broadcasting a message out to all of the clients. And this is super easy to implement. You'll also notice that there's no on close function handler because we just don't need it in this circumstance. And so you can omit it without any problems. All right, so let's check it out. So here I've got this little click demo project that I'm working on. So I've got this little click demo project, and you can see that my project is right here, and I've only got a few files. I've got a completely empty application BX. This is just so that it has an application to work with. I've got my box JSON, which was automatically generated for me when I did the box install SocketBox. I've got my index HTML, which is a poorly formatted, let me make that even a little bit bigger, which is a very poorly formatted HTML file. You can see here that I did the absolute bare minimum. There's no HTML element, there's no body tag, there's nothing like that. Obviously, those things will probably improve the file, but this just shows you how bare bones you can get. And this is copy and pasted from that slide that I showed you earlier. We've got our server JSON, and this is basically the same, except I've added the JVM configuration to make sure that we're on the JDK21. And now let's look at our WebSocket BX. So here we've got our WebSocket BX, and this is everything that we need for the functionality that I'm about to show you. We're basically just, when someone gets connected, we send them a message, which gives them the current state of our counter. And then every time we get a message for click, then we're going to increase that counter and broadcast it out to every connected WebSocket. And so that goes for WebSockets that are from different users, but it also goes for, like, if just one person connects across multiple tabs, each tab will get a WebSocket connection. I've already got my server running in the background. So I'm going to go ahead and open that up and we can take a look at it. All right, so here we go. I've got two tabs, both open to my BoxLang server that's running. And you can see that if I refresh, they connect and they immediately show count equals 2. Now, it's not 0 because I was messing around with it before the webinar, just to make sure for the 100th time that things were going to work the way that I wanted. And I left it with a state of 2. So that's why it's already initialized. But what you'll be able to see is that if I go over here to this one and I hit click me, you're going to see this counter update, but you're also going to see this counter update, right? That's the magic of WebSockets. So if I click on this, boom. And if I click on this, they're both updating. So Very cool, very impressive, very fast. And you can see that that was like, I don't know, I want to say even with all of the boilerplate and configuration, that was maybe like 50 lines of code to be able to add that to your application. I think that is a really cool achievement. Now, I do want to kind of call out for a second just some design considerations that you need to make when you're thinking about incorporating WebSockets into your application, because you'll notice that there was a shift from in our code. The count variable really lives on the server, not in the JavaScript application. And so there are some subtle shifts that you need to make in terms of like architecture when your data is going to be living on the server. This is where it's really important to make sure that you understand the challenges of working in a load balanced environment with this. In this example, it's really simple because I've got one server, right? And so all of my WebSocket connections are going to be on the same server. But let's say that I had 3 servers running in a cluster. Well, if I opened this tab and I connected to server A, right? And then I opened this tab and I connected to server B, but my counter variable is being stored in the application scope. Well, that means that server B's count is going to go up when I do this, and server A's count won't, because those are technically 2 different applications, even though they're running in a cluster together. That's a totally solvable problem. And as I mentioned earlier, that's something that SocketBox has done a great job of solving. So we'll cover some of those strategies there. But I just want to help. If you haven't worked with WebSockets before, that kind of challenge can come a little bit as a surprise. But it really makes sense when you think about it. You know, this is the same type of issue that we run into when we are moving to sessions in a load balanced environment, right? If you have a single server that has sessions, everything's great. But then as soon as you start adding more servers to your cluster, you're going to end up in a situation where one server has your session and another one doesn't. And, you know, in this day and age, we have a million different solutions to that problem. We've got sticky sessions, we have database backed sessions, we have Redis backed sessions. And so that is going to be basically the same. Those style of solutions are going to be the same solutions that we have available to us in SocketBox for solving these problems. All right, so let's get back to our presentation. All right. Okay, so let's talk about going beyond the basics. Like I just showed you, this demo works. It's very easy to set up. It's got a lot of cool potential. But how do we handle things like in the real world, like multiple servers, authentication? What happens when your application finally takes off and you're the new Twitter or something like that? How are you going to handle the complexity that comes along with that? There's a couple of things we're going to talk about that, and I think it'll become clear to you. So one of my recommendations for if you think your project would benefit from WebSockets and you think that it's going to grow past any level of complexity, I would strongly encourage you to consider how STOMP works, to learn about that and see if it's right for you. It is a little bit more complicated to set up, but we've got a blog post about that, and it's going to help solve a lot of those problems for you, or at least give you a framework for how to solve them up front. So I would really encourage you to look into that. We'll do a quick overview of that here. So STOMP stands for Simple Text-Oriented Messaging Protocol. And without STOMP, you have to solve all of these problems for yourself. Message format and serialization, whatever your protocol is going to be, like, in the examples we looked at, we were just sending a simple text string like click or hello or whatever. And that can work great for a little bit, but then it can get really hairy later on. It also, sometimes you might run into a situation where you have a lot of clients connected to a server and you want the clients to be able to kind of communicate with each other. And maybe the server doesn't really care what they're saying to one another. It's just transient data that it's great if you have it, but it's also okay if it gets lost or something like that. Well, if you haven't used STOMP, you have to actually go in and manage and touch all of that data to get it where it needs to go. But STOMP has a really interesting topic subscription and routing framework, refers to as exchanges, which we'll look at. It also provides you a really simple way to implement authentication and authorization through a couple of listeners in your WebSocket BX. And then it also handles automatic reconnect and a health check, heartbeat kind of messaging thing to make sure that your client is still connected. So basically, STOMP is easier to implement than stick in later. It would be a refactor more than an upgrade. Yeah, I would definitely agree with that. I mean, if you end up skipping STOMP early and then having to refactor, and then your application grows in complexity and you want to refactor to it, I think that could be a really big headache, and it could especially if you don't have like automated testing or something like that, you might miss edge cases. I think for me, it really boils down to STOMP is kind of in that category where it looks like more trouble than it's worth at first, to be totally honest. But the learning curve, once you get over that, you spend a couple of hours reading the spec and understanding it, it becomes clear, and then it's kind of a no-brainer at that point. So I would really encourage people who are considering it to just take the deep dive, get the learning over with, and then reap the benefits down the road. You can kind of think of it as a pub sublayer on top of raw WebSockets. So let's look at security and STOMP. The first thing I want you to notice is that we are no longer extending the WebSocket core class. We are extending WebSocket STOMP, which in turn extends WebSocket core. So you're going to still be getting access to all of the things you had in WebSocket core, but you're going to get extra things with WebSocket STOMP to help with that, to help with implementing and conforming to the STOMP standard. And so there's a couple of functions here that are going to be added to that. The first one is authenticate. When a client connects to your STOMP server, they have the ability to pass through some credentials. Now, you can get the credentials out of the request, which is where login and passcode will come from, or you can also get access to cookies here. So if you're doing session-based authentication, you have access to the cookie scope, and you can look at their token that way. And then here you can just check some things like, this is just a hard-coded login equals admin, passcode equals secret. Please don't implement this pattern, but I think you can understand where we're going with this. You could get out the value and check it against your database. You could hash it. It could be assigned JWT. That you verify first. You can do any number of things here. The most important part is just that you return true or false. And then we have an authorize function. This is called specifically when a client attempts to listen to or create a subscription to a STOMP exchange. Now, we'll cover some of those topics a little bit in more detail in just a moment, but the idea is a client has requested a specific exchange. The information of the client will be sent along, and then specifically the exchange that they want to listen to will be here. And then you can use that to decide if they're authorized. So a quick example would be, maybe you have your exchanges set up with something like some sort of naming convention. Like you have admin events, which would be like admin.orders, admin logged in users, admin.whatever, right? And then you could have user level exchanges, which are like user.job counts, user.job completed notification, whatever. So when a user tries to subscribe to an exchange, you could check and see, okay, are they an admin? Then we're going to let them go for, it doesn't matter what the channel is named or the exchange is named. We're just going to let them listen to everything. Then someone else tries to connect, and we check the database and find out that their user is not an admin. They are just a regular user of the system. If we then see that they're trying to connect to an exchange called user job completed notification, then we go ahead and we return true because they're allowed to listen to those ones. If they try to connect to a different exchange that is prefixed with admin dot, then we would say, oh, hold on, you're just a regular user. You're trying to connect to an admin exchange. We're going to return false in that circumstance. So you can see it's a pretty easy thing to implement here. Another function I want to draw attention to in when you're implementing this, or when you're extending this class, WebSocket STOMP, you'll get authenticate, authorize, but you'll also have access to something called configure. When you override this function, you can provide a configuration struct that tells your STOMP broker how to behave. There's a lot of configuration that you can put into this. I'm only going to draw your attention to it, and I'm going to tell you about exchanges. If you want to know more about this, I would encourage you to read the blog post, as well as to go and read the SocketBox documentation where it actually covers this. You can find that on ForgeBox. But basically, the important part here is that when you're working with STOMP, you need to configure your exchanges and your subscriptions. Exchanges, you can kind of think of them like mailboxes. And I hear this, a lot of people use this analogy of STOMP being like a mailroom in like a big office building or something like that. And so an exchange would be kind of like a mailbox. And when mail comes in, it first goes to a mailbox in the mailroom. And then it's after that an office mail person will go to that mailbox, see that it has a message, and then they'll think about the rules for that mailbox before they distribute it. So that allows you to do some kind of convenient things. Like here, if something goes to the direct exchange, then you can have it go to other exchanges. So this is basically just like simple alias routing. Topic allows you to use wildcards, like here the pound is a wildcard. So you could orders dot whatever would match both orders dot shipped and orders dot canceled. Fan out allows you to create like a one-to-many exchange where it comes in on one thing and then it gets sent out to multiple other ones. And then this distribution one, I'm sorry, it's hard to read here, but it's basically like a round robin thing. So you can have, if you're going to exchange A and that's set up as a distribution, then it could do a round robin forwarding to like destination B, C, and D in order. Okay, now let's also talk about subscriptions. This is something that was actually a little bit confusing to me. So hopefully by drawing attention to it, I'll make it easier on you guys when you're implementing this in your application. But in the world of STOMP, they have worked really hard to completely abstract the routing of messages. And I kind of had this assumption that the server gets to listen to every message that goes through, but that's not actually the case. In STOMP, your server is treated almost like just a regular client. So your server has to actually subscribe to a message if it cares about processing it. On one hand, that's really weird and kind of made me uncomfortable the first time I was implementing it. But then I realized that that's actually really convenient because you can network all of your different exchanges together very easily just with some configuration. And then you can set up the server to only listen to and care about the actual data that it wants to process. And that's very simple. So in your subscriptions, you just put the name of the event or of the message that you want to listen to, and then you throw in a closure here to be able to respond to that message. So very easy to implement, but like I said, a little bit extra boilerplate. Now, another thing I'll kind of point out is that this can make it a little bit confusing to know how to send a message to a specific user, but that's where kind of getting creative with your exchanges can help out with that. So if you want to, like what I've done in previous applications is I'll create a topic exchange and then I'll have like user dot and then the user ID, right? So we'll actually have dynamic topics that can be listened to and broadcast to. And then that way, if user 5 tries to listen to user.6 events, then they won't be authorized to do that. I'll check that in the authorization handler and reject them. And then whenever I want to send a message to, user 9, maybe their records are ready for viewing or something like that, then I can just broadcast to the topic user.9. whatever and be confident that only user with ID 9 will get that information. But the other great part of that is, if you remember, I mentioned that you can get a WebSocket connection for every tab that you have open. Well, if user 9 has 15 tabs open, you can just target them categorically using that subscription and exchange model. And that's where there's a little bit of a learning curve. But like I said, it pays dividends later on in your application's scaling. So highly recommend that. Okay, so let's get to load balancing. And unfortunately, we're kind of getting close to the end of time here. So I'm going to kind of move through these things a little bit quicker. But like I said, there's tons of information on this already. So I would definitely encourage you to check that out. And we kind of covered a little bit of this earlier. So hopefully you guys will have the information that you need. We'll also be having some talks about SocketBox at ITB this year. So if you're interested in more about this, you could definitely pick up the virtual ticket and tune into some of those. I think Eric is going to be doing that one. So that'll be really excellent. So when you're load balanced, WebSockets can be a little bit tricky because you're getting a specific WebSocket connection to a server, but the data or the events that you're listening to may be happening on other servers. So you have to route those together. Also, you could run into a situation where the specific server you're listening to goes down and then your WebSocket connection has to recover. And if your WebSockets are set across multiple servers, you're going to have trouble getting the clients to be able to communicate to each other because they're kind of sandboxed to their specific server. So the way that we handle this is with built-in cluster support. Brad has built in a way for you to have a shared cache provider. And you basically just have to, it's kind of like a duck typing thing where you have to basically just provide something that has like get and set functionality. And then that's going to be able to work as your cache. So this is the simplest, I think probably the most common implementation that I think that people will be using when they implement SocketBox. And that is using a CacheBox cache. This has been working really great for me in production. I've had zero issues with it. And this makes it really simple to swap out a cold different types of ColdBox caches for your SocketBox cache. So you can see here, we configure a secret key, which the WebSocket servers need to communicate with each other. If you remember, I mentioned that they actually create WebSocket connections to one another to coordinate their state, and they need this secret key in order to be able to do that securely. So just make sure that you distribute your secret key to all of them. And this can just be like a GUID or something like that. And then here for cache provider, you can see I'm doing application.wirebox get instance, targeting the cache box provider and getting out a cache that I've configured in the ColdBox configuration. Usually this ends up being like a Redis cache, but it can be a database one, it could be a file, whatever you want. There are other options for this. If you want to write your own cache provider, it's actually easier than it sounds. You should definitely check out, this is the blog post about deploying behind a load balancer. You can just Google that or look at the links in the chat, and you'll be able to see some examples that I've added to that blog post. All right, so we've reached the end of our webinar. Here's a couple of extra resources that I want you guys to be able to have. We've got an example repo, github.com, jbeers, SocketBox intro. You can pull this down and mess around with it. I've taken a lot of care with this. So if you look at the Git history, I've created tags that go along with the different blog posts. So if you're reading Hello WebSockets, you can clone SocketBox intro, switch to the tag for that blog post, and follow along. Same with these other ones. I'll also draw attention to the deploying behind a load balancer one. In this repository, there's actually a working code set up that allows you to run 2 CommandBox servers and have them in cluster mode together with WebSockets. So you can see that in action and copy and paste it if you need to. This is also where SocketBox lives on ForgeBox, so you can see the documentation. Here's our blog series. You can check those out. And as always, we are on Slack. You guys can reach out to us on the Box Team Slack, and we'll help you with any questions or issues you run into. So, all right. Thank you, guys. We got a couple minutes left, so if there's any questions, I'd be happy to answer them. But other than that, thank you for attending this SocketBox webinar. I hope it was helpful to you, answered some questions, and inspires you guys to go out and write some really cool SocketBox applications. I think there's a huge amount of potential for SocketBox in the BoxLang and CFML ecosystems. And I really think that the sky's the limit on what this can add to an application. Any water cooler with using the sockets with CB wire? That's an interesting idea. I actually haven't spoken with Grant about that at all, but that makes a lot of sense. I think that's a really interesting application. I do know that Grant has implemented something called server-side events, which is kind of like a WebSocket's like cousin, I guess you'd say. So he may have kind of already solved that problem in another way. But yeah, good question. Thanks, Adrian. Let's see. George is asking if it allows embedding of images. And yeah, I mean, you can send whatever data you want over the wire. I think it ultimately has to be encoded as a string, but you could do like a base 64 encoding and then send it over. Oh, you could do a base 64, put it into a JSON packet, and then send that out as well. You may also want to do something where maybe you just send the event that, hey, your image is ready, and then the client can get that notification, get that event from the server, and then make a second request specifically for the image. It gives you a lot of flexibility and options for that. All right, great. Well, thank you guys for joining the webinar, and I hope to see you all at ITB or on Slack. Have a good weekend.